Today we're on page 5 of our Chapter 6 notes packet, Section 6.3 Sigma Notation, and Section 6.4 Arithmetic Series. When the terms of a sequence are added, it's called a series. Summation notation, also called sigma notation, is used to write a series. This symbol here is the uppercase Greek letter sigma. What this stands for, okay? This here, we have the summation of n going from 1 to 4 of the expression 2n. N is the index, 1 is our lower bound, 4 is our upper bound. Our expression is 2n. What we do is we substitute, starting with 1, in for n, and increase by 1 each time until we reach our upper bound. So we'll put in 1, then 2, then 3, and then 4, and then add them all up. To expand sigma notation, substitute n equal to the lower bound, then increase by 1, substitute n, increase by 1, substitute n, until the n is equal to the upper bound, and add all of these terms up. So here we have 2 times 1, which is 2, and then substituting 2 in, 2 times 2, which is 4, and then substituting 3 in, 2 times 3 is 6, and substituting 4 in, 2 times 4 is 8. So the sum of terms is this 2 plus 4 plus 6 plus 8. So writing this as the sum of terms, it's 2 plus 4 plus 6 plus 8, and the actual sum itself is 20. The next example, instead of an n, we have a variable j. This is the summation of j starting with 5 going to 9 of the expression 5j plus 3. So we'll substitute 5 in for j. So we have 5 times 5 plus 3. 25 plus 3 is 28. Then we'll substitute 6 in for j. 5 times 6 plus 3. 5 times 6 is 30 plus 3 is 33. Substitute 7 in for j. 5 times 7 is 35 plus 3 is 38. Substitute, what did I leave off with? 8. 5 times 8 is 40 plus 3 is 43. And substituting 9 in for j, 5 times 9 is 45 plus 3 is 48. So the sum of terms is 28 plus 33 plus 38 plus 43 plus 48. So writing this as a sum of terms, you write the terms as a sum, and the overall sum is 190 if we were to add these all up. We want to write each arithmetic series as a sum of terms and compute each sum. So for number 1, we have the sum of 2k plus 1k starting with 3 and going to 6. All right, so this would equal 2 times 3 plus 1 plus, substituting 4 in for k, 2 times 4 plus 1, then substituting 5 in for k, 2 times 5 plus 1, and running out of room here, 2 times 6 plus 1. 2 times 3 is 6 plus 1 is 7. 2 times 4 is 8 plus 1 is 9. 2 times 5 is 10 plus 1 is 11. And 2 times 6 is 12 plus 1 is 13. So the sum of terms, 7 plus 9 plus 11 plus 13. And then the actual sum, 7 plus 13 is 20, and 9 plus 11 is 20. 20 and 20 is 40. Next, number 2. We want the sum of n squared minus 1, n going from 1 to 5. So we're substituting 1 in for n. So we have 1 squared minus 1, then plus, plugging in 2 for n, 2 squared minus 1, plus 3 squared minus 1, plus 4 squared minus 1, plus 5 squared minus 1. 1 squared is 1, subtract 1 is 0, plus 2 squared is 4, subtract 1 is 3, plus 3 squared is 9, subtract 1 is 8, plus 4 squared is 16, subtract 1 is 15, plus 5 squared is 25, subtract 1 is 24. So this is our sum of terms, 0 plus 3 plus 8 plus 15 plus 24. Adding this up, 24 and 11 and 15 is 50. Next, we want to write in sigma notation. Okay. Well, how many terms do we have here? 1, 2, 3, 4, 5. We have 5 terms in this series. So n equals 5. So our upper bound would be 5 terms. We cross off n equals 5 and just say we have 5 terms. So our upper bound is 5. So when we'll be going from 1 to 5. Now, what's our expression? Well, we need to figure this out. This is an arithmetic series, so what's the common difference, all right? If we were to list our terms, not as the sum of terms, but just as the arithmetic sequence, 5, 9, 13, 17, 21, let's come up with a rule for this. What's our common difference? Well, it's 4. 9 subtract 5 is 4. 13 subtract 9 is 4. A1, our first term is 5. Okay, so now plug into the formula. AN equals A1 plus D times n minus 1. Going back to our arithmetic sequence formula. So AN equals A1 is 5. D is 4. And simplify this. This is equal to 5 plus 4n minus 4, which is simply, I apologize, I'm running out of room here. This is going to be 4n plus 1, right? 5 subtract 4 is 1. So this is our expression. So we want the summation of our expression 4n plus 1, n going from 1 to 5. And we can check this. For on the calculator, summation using the calculator is alpha window number 2. Right. And again, I'll show this to you in class tomorrow if you don't have a calculator. Alpha window number 2. There it is. Right. Here we always use x for our variable in place of n. Going from 1, arrow up, takes you to the upper bound, would be 5. And our expression goes in the parentheses, 4x plus 1. And it'll give us the actual sum. Right. We weren't asked for the actual sum in this case, but if asked for it, there it is, 65. We could use the calculator to go back and check number 2. Right. Again, not everyone may have a calculator at home, so we'll do this tomorrow in class. Okay, next we want to take this, write in sigma notation. All right, well, this doesn't look like an arithmetic sequence. So we have to come up with our rule, though. This is our first term. This is our second, our third, our fourth, fifth, sixth, seventh, and so on. Okay? Well, what do we do to 1 to get 3? Well, we could add 2 to it. So if I take my value of n and add 2 to it, does that work for the other numerators? 2 plus 2 is 4, 3 plus 2 is 5. Okay, now how about the denominator? What do I do to 1 to get 4? If I add 3 to it, does that work for the other denominators? Let's see. Yep, 2 plus 3 is 5, 3 plus... Okay, so this is our expression. Our expression is here. N plus 2 divided by n plus 1. So we'll write this as a summation of n going from 1 to 7, right? That's what I have there. N plus 2 divided by n plus 3. On to page 6. If you add the terms of an arithmetic sequence, it's called an arithmetic series. An arithmetic series. The sum of the first n terms of an arithmetic sequence is, this formula is given to you, you don't have to memorize it, the sum of the first n terms, capital S for sum, subscript n, sum of the first n terms is equal to n times, parentheses, a sub 1, the first term, plus a sub n, the nth term, divided by 2. To use this formula, you must know the first and the nth terms, a1 and an, of the sequence. If you don't know them, then you use the formula a sub n equals a1 plus d times n minus 1 to calculate them. In these exercises, we want to find the sum of the first 20 terms of the arithmetic sequence. Use the above formula, and then we're also going to use sigma notation to indicate the sum. So we're using the formula to find the sum. We're doing two things here. And then we're also using sigma notation to indicate the sum. All right, so our steps, we want to write what D, A1, and N is. Use A sub n equals A1 plus D times n minus 1 to find A sub n. And then use the above formula for S sub n. And we're finding the first 20 terms. Okay, the first 20 terms. Okay, so D value first. Common difference here, 8 minus 4 is 4, 12 minus 8 is 4. We need A1. A1 is 4. Okay. Our N value is 20. We want the sum of the first 20 terms. So now we also need to know what the 20th term is. So we use our formula. We know that N equals 20. We use the formula that A sub n equals A1 plus D times n minus 1. And we want the 20th term. What's its value? Substituting our values for A1 and our value for D. And 20 in for N. All right, so this is 4 times 19, which is 76, plus 4 is 80. So our 20th term is 80. All right, now I'm taking the formula that's given to us. S sub n equals n times A1 plus AN divided by 2. So the sum of the first 20 terms, this is what this means, the sum of the first 20 terms is equal to 20 times A1, the first term, 4, plus the 20th term, which we found was 80, divided by 2. 4 plus 80 is 84, and the 20 divided by 2 is 10. So 84 times 10 is 840. And of course, you're more than welcome to work that out on the calculator. You don't have to use the same steps that I did here. 84 times 20 is going to be 168, or no, times 20 is going to be 1680, divided by 2 is going to be 840. Now, so this is the sum of the first 20 terms of this series. Now we want to use sigma notation to indicate the sum. Okay, so for sigma notation, we're finding the sum of the first 20 terms. All right, so it's going to be the sum of n going from 1 to 20, and we need the expression. Okay, we'll go back to here, right? We're using this formula, leaving n as the variable. A sub n equals A1 is 4 plus D is 4 times n minus 1. Distribute the 4n minus 4. So it looks like combining we have 4n. So sigma notation is simply the summation of 4n, n going from 1 to 20. Let's try the next one. Okay. We want to use the formula from above to find the sum, and then we want to express the summation in sigma notation. Okay, so we need to find D. 16 minus 6 is 10. D is 10. A1 is 6. And n is 20. What is the 20th term? We need to find the 20th term. So A sub 20 equals A1 plus D times n minus 1. A1 is 6. D is 10. And n is 20. 20 minus 1 is 19. Times 10 is 190. Plus 6 is 196. So our 20th term is 196. Our sum of our first 20 terms is going to be n times A1 plus AN divided by 2. N is 20. A1 is 6. Our 20th term is 196. 6 plus 196 is 202. Times 20 divided by 2 is going to be 220. Next, sigma notation. We need to come up with the rule, right? We need the rule. So we're going back to this formula, but only leaving A sub n in there as our variable. So A sub n equals A1 plus D times n minus 1. The first term is 6. Our D value is 10. Distribute 10. 6 plus 10n minus 10. So this is 10n minus 4. Okay, so continuing here. So this is our rule, or our expression. So we have the summation of 10n minus 4, n going from 1 to 20. And next, number 3. We have the fourth term is 2. D is negative 2. We need to find A1 first. Okay, we need to find A1 first. Okay, we know what the fourth term is. So let's take our a sub n equals a1 plus d times n minus 1. And we're putting in 4 because we know what that is. Replacing d with negative 2. Our fourth term is 2. So 2 equals a1 plus 4 minus 1 is 3 times negative 2 is negative 6. Now add 6 to both sides. And the first term, a1, is 8. Okay, we know the first term, the 20th term, right? Because we need the sum of the first 20. So this is going to be the first term, a1, which we found to be 8, plus the d value, which is negative 2, times 20 minus 1. 20 minus 1 is 19, times negative 2 is negative 38, plus 8 is negative 30. So our 20th value is negative 30. So the sum of the first 20 terms is equal to n times a1 plus an, in this case 20, divided by 2. So 20 times the first term a1 is 8. The 20th term is negative 30, divided by 2. 8 and negative 30 is negative 22, times 20 divided by 2 is going to be negative 220. So this is our sum of our first 20 terms. And now expressing this using sigma notation. And we're always falling back to our a sub n equals a1 plus d times n minus 1. Finding the rule, a1 is 8, d is negative 2. Distribute the negative 2, 8 plus negative 2n plus 2. So our rule is an equals, we can write this as 10 minus 2n or negative 2n plus 10. And summation notation, the sum of n going from 1 to 20 of negative 2n plus 10. Okay, you can try number 4 if you like, otherwise we'll work out number 4 in class together. This concludes tonight's video.